for these that we fill in that formula sheet, and you'd be able to match it to the formula sheet. So what's going to happen also is like this picture looks just like one that we did yesterday. But the difference is we're not talking about the angles this time. We're talking about the lengths of the sides. Okay, so that is going to be important for you to think about when you look at a question. You need to ask yourself, is it asking me for the length of the side, or is it asking me for an angle? Because this section here is segments, and segments are going to be, yeah, if you want a highlighter, just go ahead and pass those around there. If you want a highlighter, grab one there and pass those around. Segments are going to be length of side. I've changed my pen and made it too big here. Hold on. Let's see if that's better. It's a little better. These are not angles. Okay, so not angles is what we're talking about in 6.3. So if you get a question that's asking you for the length of a line, then you need to look in the 6.3 section, not the 6.2 section, okay? Because a lot of the pictures look the same. Like this picture looks the same as this picture right here when you look at the just the picture. But this one deals with angles, and the one we're getting ready to do is the lengths of the sides. In my opinion, this is the easiest one. In this one, A times B has to equal C times D. So it is the pieces of one line multiplied together have to equal the pieces of the other line multiplied together. So if I look over here at this example to do this, I'm looking at one line, and I'm multiplying those pieces together. So I'd have 27 times 16. And that will be equal to the pieces of the other line right here multiplied together. So that would be 24 times x. And so the numbers are a little big, but we can use our calculator, so that's not an issue. We just need to do 27 times 16, and we will get 432. So we got 432 equals 24x. Keely, what do we need to do to solve that equation now? Yeah, just divide by that 24, and when we do 432 divided by 24, we are going to get 18. So x equals 18. Okay, questions on that? You got the biggest mistake kids make on this is they do like 24 times 16 equals 27 times x. They use the wrong pieces. It's the pieces of the same line multiplied together equal the pieces of the other line multiplied together. All right. Okay. Let's add that to our. Well, I don't know. I think we'll do our formula sheet last. We'll go back over these to add this to the formula sheet. So here is our next one. Okay. These I have a little trouble keeping straight. I will be honest about this. A little trouble keeping them straight. This is a secant. Remember, a secant line. A secant line is the line that goes through the circle and then outside. So that blue line is our secant line, and the red line is your tangent line. The tangent line doesn't go through the circle, it just touches the circle. So we've got a line that just touches the circle and then a line that goes through the circle. So whenever we see this, it tells us to do a squared. So if you want, you can think about that being the tangent squared is going to equal b times b plus c. And so the way I usually write that, b is your outside part of the line, and then b plus c is the whole line. So these are a little bit trickier, but definitely still doable with the formulas, right? So when I look at this picture here, which one is my tangent? The 12 is my tangent. This line right here is my tangent line. So that is going to be the A in this case, right? That's our A. So we're going to do 12 squared. Then we'll do equals. And then the other one is my secant line. And B is the 9. That's the outside part. X is your C. That's your inside part. So you do the outside, which is 9, times the whole thing, which would be 9 plus X. Okay, so it'll set up an equation for you that we have to solve. Our first step, we would just need to square that 12, so we'll get 144 equals, and then over here, we can distribute that 9. So 81 plus 9x. See, how do we finish solving that equation? Perfect. Subtract that 81. So 144 minus our 81 is going to give us 63. I'll have to go over here. I ran out of room. So 63 is going to equal 9x. And then how do I finish that one off? Divide by 9. And that is going to give us 7 for our x. Okay, questions? Okay, we got some more coming up. Okay, this time we have our two secants intersecting outside the circle. So in this case, they're both secants. They go through the circle. So it's similar to the other problem for the secant part of it, right? Because if I have A times A plus B, that would be my A right here is the outside part of the line, and A plus B is the whole line. And then over here, C is the outside part, and C plus D is the whole line. So we're doing outside times whole for this. So if we look at this picture right here, the outside part for that first secant would be 7. And then the whole thing would be 7 plus 5. Or if you wanted to, you could go ahead and put 12 for that. On the other line, Angel, what's the outside? What's the outside part of this other line? All right, 6. And then what's the expression we'd use for the whole line? 6 plus x. So if you can get the equation set up correctly, you should have an equation that is going to be a pretty short equation with just a couple little things to do. So 7 times 7 plus 5, you can just do in the calculator. We get 84. So we got 84 equals. And then over here, I would distribute the 6. So you got 36 plus 6x. Scarlett, how do we finish solving that one? Good. And so 84 minus 36 is going to give us 48 equals 6x. And then what would the last step be, Scarlett? Divide by 6. And when we do that, we will get x equals 8. For that. Yes.
So would it matter if you just not combine like terms? Instead of just doing what you did on the calculator?
What do you, like if you did like 7 plus 5 is 12, or?
No, like you got like 12 times 7 is 49.
7 times 5 is 35. It's fine because that is still 84 if you put it together. Yeah, so you could do it that way. Okay? All right, questions here? All right. Moving on. Okay? You have 4 questions here. They are all mixed up now. This is what's difficult to do a lot of times, to know when to use what rule. So I'm going to give you about, 10 minutes or so, however long it takes, since I want you guys to try these problems. Okay? So if we go on, there's just a couple more things that we need to know about. Congruent chords. If 2 chords are equidistant from the center, thank you. If 2 chords are equidistant from the center, they are congruent to each other. The line perpendicular to the chord bisects the chord. So, if you have 2 chords here that are equal to each other, they are also, or if they're the same distance away, they're also congruent to each other. So let's put some markings on this. Right here, if this right here equals this right here, so they're the same distance away from the center, then it means those 2 lines have to be equal to each other. It also means that the lines right here have to be cut in half. So that would mean this piece is equal to this piece, and this piece, and this piece. All 4 of those pieces would be the same. So if we see a problem like number 8, we have a perpendicular line right here going to a chord, which is going to tell me that this chord right here gets cut in half, right? So if this piece right here is 9.8, what would this piece over here be? Also 9.8. How would we find our x in this scenario? What shape do we have right here? Specifically a right triangle. When we have a right triangle, what can we do? Well, it is a 90-degree angle with the the sides, there's something we should know about those sides. They are not all the same. A squared plus B squared equals C squared. We could use Pythagorean theorem because we're looking at this right triangle right here. Which side is my hypotenuse? Which side is the C in this case? Which side would be the hypotenuse? 4.8, 9.8, or X? It's X. Because it's the side, the hypotenuse is always across from that right angle. So, in this case, it doesn't matter which one's 4.8 and 9.8. I'm going to do 4.8 squared plus 9.8 squared. Those I could switch. It doesn't matter what I do with that, but my X squared has to be over here on the right-hand side. And so, to solve that, I can type 4.8 squared plus 9.8 squared into the calculator. I get 119.08. Like so. And then, what am I going to have to do to solve that? Square root. To get rid of a square, we square root. So square root 119.08. And we get 10.912. Let's go 3 decimal places. 10.912 is our X. Okay, questions? Okay, just a couple more things that we need to know. For tangents, a tangent line is perpendicular to the radius, drawn from the center to the point of tangency. So if you have a radius that goes to a tangent, they are perpendicular. You have a 90-degree angle right there. So that's just really a property that we have to know. So if they were to like draw in a triangle, we might have a right triangle we could do Pythagorean theorem with. We also have another property for tangents. Two line segments that share an end point and are tangent to the same circle must be congruent. So if we have a two line segments here that are tangent to the circle, so this barely touches the circle here, this one barely touches the circle here, they have to be the same length. Okay, questions? Okay, let's work through a few examples that involve some of this. Okay, so for number 9, we have a big triangle drawn, and they are asking us for this piece right here. That's what we're trying to find. However, we're probably not going to be able to find just that piece. We probably need the whole line there, and then what could we do? If we found that whole line right there, what could we do with it to find this piece? Just divide by 2, because that's a radius, right? If we find the diameter, we just have to divide by 2 to get the radius. Now, is this a right triangle? It is. How do we know it's a right triangle? Because it's not marked. Okay? In this corner right here, you're going to have a right angle because this is a tangent and this is a radius, and we just said tangents and a radius have to be perpendicular to each other, right? So this is a right triangle. That means we can do a squared plus b squared equals c squared. Okay? Which side is my c here? The 14. So I'm going to do 8.4 squared plus b squared equals 14 squared. And then 8.4 squared is 70.56. I think 14 squared is 196. Let me check. Yep. And then once we get that, what would we have to do to solve for that b? Angel, what do you think? Subtract that 70.56. So b squared equals, we're going to get something here, 196 minus 70.56. That's going to give us 125.44. And then, Angel, what's the last thing we've got to do there? The square root to get rid of the square. Where's the square root on the calculator since we're using those? Second, x squared. We'll get to the square root. 125.44. 11.2. So, oh wait. Is that our answer? Because that would be the length of the whole side of this diameter, right? That diameter would have a length of 11.2. What do I have to do to find my answer here? Divide that by 2. So 11.2 divided by 2 is going to give us, what, 5 point something? 5.6. So 5.6 is our final answer there. Okay. I'm going to skip down to 11. For 11, what would I do there? What do you think? Is there... What? Okay, we can make it into an equation. I think we need to do that. What can we set equal in this equation? Do we know pieces that have to be equal here? What is it, Angel? Those two have to be equal to each other because they are both tangents, and that was just on our last slide, right? Tangents to the same circle have to be equal to each other if they're coming from the same point. So we just have to do 4x minus 12 equals 2x plus 12. Jeremy, how would I solve that equation? How do I do that? I mean, yes, but which one from which side? So you're going to subtract 2x or subtract 4x? Okay? It doesn't matter. You can do it either way. I would do it this way so that you don't have to have a negative. Okay, what would be next, Jeremy? Add the 12. Good. So we're adding that 12. So we got 2x equals 24. And then last step, Jeremy, divide by 2. So x equals 12 for that. Okay, 12 is a little bit of a different problem than what we've had before. If we look at back at our pictures, this is a tangent and a secant, right? Which meant that we did tangent squared equals outside times the whole line, right? So let's make this question mark into an x because we don't know what that is. So if we're setting this up, we'll have x squared equals outside, which is 6, times the whole thing, which is 6 plus 9. And so setup is pretty much the same, but solving is a little bit different because we do have an x squared here, right? But everything on the right-hand side can just be typed into the calculator. So we will have 6 times 6 plus 9 here. Hello? Sure, turn your lights in right there. Thanks. Angel, you are leaving. Let me give you your worksheet. That'll be our assignment, and we're gonna. Yeah, there's also that practice quiz online. And so whenever we do this, we got x squared equals 90. What do we have to do next? How do I get rid of a square? Square root. And so square root of 90 is going to equal 9.487. Okay, questions? All right, this is our last piece that we are going to do, and I didn't put the directions on this. I think it is looking for the perimeter. That's what it's looking for. So let's do one of these. This is looking for the perimeter, I believe, on this. I forgot to put the instructions on that. I think it's looking for perimeter anyway. So that'd be the length all the way around. But we don't have this side right here, right? So what's important to remember whenever you're doing these problems is that this piece would equal this piece. This piece equals this piece. This piece equals this piece. And this piece equals this piece. So this is 4.3 right here. Then this piece right here is also 4.3. That means if this is 10 right here, what would the length of this piece right here be? Also 10, right? That makes it where we can find this piece right here. What would that be? It's going to be 5.5 because the whole thing has to add up to be 15.5, right? So if we do 15.5 minus 10, we'll get 5.5. Well, if that is 5.5, this piece is 5.5. Okay? So let me switch to a different color. What does that give us here? 8.5. Right? We can just do 14 minus 5.5 to find this piece. And if that is 8.5, what is this piece right here? 8.5. So what we can do here now that we know all of our pieces is we can just add them all up because that's how we find perimeter. So you could do the little pieces or you could use the whole side. Like this whole side right here is 14. This whole side right here was 15.5. This one right here is 14.3 if we put the 10 and the 4.3 together. And then I'm just going to do this. I'm going to do parentheses 8.5 plus 4.3 right here for that side. And we get 56.6. Okay, questions? 14 similar, we're not going to do it because we need to add these to our formula sheet. So let's look at our formula sheet here. Alright, so we'll do it over here so I've got one to look at this time. Alright, these are going to be on the back side. Here, these are the ones we've looked at today. So, for the first one, if we've got A, B right here, it's going to be A times B equals C times D. We'll color code a little bit here. You can highlight if you want. Okay. For our secant tangent intersecting outside, we would have our tangent squared. So we'll have A squared, or if we want, we could write down here underneath it tangent squared equals, and then we've got B times B plus C. And that we can think of as the outside times the whole. Sorry, I'm running off the page there. Okay. For our secant, it's a lot like the tangents, but it's just both of them are this side. So it's going to be A times A plus B, which we can think of as the outside times the whole. And that will equal C times C plus D, which is the outside times the whole. Okay. We just need to mark a few things on these next problems. The congruent chords, if you have two chords like this little piece right here is equal to this piece. And then this piece is equal to this piece. And this piece is equal to this piece. For the picture down there on the bottom left, you just need to draw in a right angle here, and I'm going to write tangents and radii are perpendicular. Okay, and then the last picture, you just need to mark these two lines right here congruent to each other. Those two have to be the same. All right, I need you to pass out your assignment. Let's do these numbers. So I'll write it up here. You'll be able to see it better. We're going to do your homework. I want you to do 1 through 11 odd. And then I want you to do which one do I want you to do? 17. And 21. And 23. Okay. So those will be the ones assigned. I try to keep it pretty short so that you can also go look at that practice quiz tonight. For all of these, you at least have to show me how you set up the equation. If you come in here with just the answer written down, you will not get credit for the problem. Okay? So at least write down how you set up the equation for it, because all of these pretty much require an equation.